Thank you for joining our Get Your Data Ducks in a Row webinar focused on the value of data engineering. My name is Brandon Schulte, and I'm the Director of Marketing Technology at Zirous. We are excited that you decided to join our presentation. Before I turn the presentation over to our speaker, I wanted to quickly give you some background on Zirous and Justin Moen, our presenter today. At Zirous, we strive to be true technology partners with you every step of the way. Zirous is well-versed in navigating the ever-changing technological landscape. With nearly 35 years of experience in the technology industry, Zirous is the right partner to set your business up for long-term success. Founded in 1986 and headquartered in West Des Moines, Iowa, we work with clients all across the Midwest and beyond. Zirous's philosophy is to take a business-first approach and use technology to solve business problems. We've constructed our services around this philosophy. Each solution supports many critical business activities on its own, but together they create holistic strategies that stand the test of time and weather every storm. Our data analytics and engineering practice believes that a company's most valuable asset, second to its employees, is its data. Zirous's data team is comprised of world-class analysts and engineers that help organizations create an end-to-end data strategy from ingestion to analysis to visualization. Our analysts and machine learning specialists work to pull insights from even the most unknown data our clients own, and our engineers work in tandem to create the necessary flow and storage of the data to automate the entire process. We help our clients get the right data to the right people at the right time to make strategic business decisions through business intelligence. Our speaker today is Justin Moen, Zirous's Director of Data Engineering Services. Justin is a business intelligence professional who has a passion for working with data. His technical data engineering skills in combination with his business savvy allow him to create robust data strategies for clients that drive real business value. And with nearly 2 decades of experience, he's come across and solved just about every data problem in the book. He's taken his experience, including a current client project at Zirous, to illustrate for us today why data engineering is so important to a holistic strategy and how to get started. With that, I'll turn it over to Justin to begin the presentation.
Thanks, Brandon. As we all know, data is everywhere and is being collected each and every day. Companies are wanting to understand how they can use the data as an asset and turn it into a competitive advantage to increase revenue and profits. As data is collected, how do we turn this data into information? The next step is where data engineering comes into play. What is data engineering, you ask? Let's find out. As you can see in the picture of the data science of hierarchy needs, data collection is at the base of the pyramid, and AI, artificial intelligence and deep learning, is at the top. Data engineering falls right in the middle of this hierarchy. Often when we talk to an organization, they discuss the desire for reports and dashboards and to do some artificial intelligence and machine learning. Before we can get to the reporting and AI, we will talk about their source systems, their database, their CRM, their accounting systems, and other data sources, and how they want to get this data to the end users. These end users could be executives, managers, data analysts, or data scientists who are using the data for descriptive or prescriptive analytics. Oftentimes we hear people say that they cannot get reports in a timely manner, or the report takes too long to run, or they have similar reports but can't get the numbers to match. To help solve this, we turn to data engineering. Data engineering is comprised of building and installing data infrastructures, building data pipelines, extract, transform, and load, commonly referred to as ETL, prepping and modeling your data, cleansing data. So data engineering is the art of providing quality and consistent data so that the end users can turn data into information. We have touched on what data engineering is, Now let's dive into the value proposition of data engineering. There are many reasons why data engineering is an important component in the data science hierarchy, and we're going to focus on a few of them now. The first one is streaming pipelines. Streaming pipelines pull data from multiple data sources on a scheduled frequency and store the data in a target source. The pipeline could be either batch processing or real time, and it could be triggered by change events. By pulling the data less frequently, this reduces the resources that are used on source systems and reduces data access time for the end users, as each process is not querying the data source over and over. Next, data engineering reduces garbage in and garbage out by improving data quality. An example of this is replacing null values with empty strings, as systems see null and empty strings as different values. Another example of this is understanding the source data and getting the data into the same format. An example of this would be percentages. If one system stores the percentage as a whole number, 10, and another as a decimal, as a 0.1, your end result could be vastly different when doing calculations using this number. When combining data from multiple data sources, names can be slightly different between systems. An example of this could be where one system has a name as ABC Inc. and another one has it as ABC Incorporated. While they're actually the same company, a user might not be able to match these up because the names are actually spelled slightly differently. Data engineering can help bridge this gap to create common keys and tie these records together. Data engineering can implement new data requests from data analysts and data scientists, as well as new data sources as well. By pulling these sources one time, this can make these data elements available for all users by only having to pull it one time. Data engineering allows data analysts and data scientists to do what they do best and not have to duplicate and repeat the same tasks over and over, whether that's daily, monthly, or even one time. Finally, data engineering allows for self-service analytics. By having clean and consistent data, organizations can feel more comfortable providing data to their end users and trust that they are getting information that is output and is consistent and accurate. A data engineer wears many hats, and the skill sets can vary depending on the organization. Some organizations will have a few data engineers who can possess and perform many skills, and others will have data engineers who are specialized in a specific skill. Let's look at a couple of these skill sets. Data engineers need to have knowledge of cloud architecture platforms such as Azure, Amazon, Google, Oracle, and Snowflake, just to name a few. Data engineers need to have data modeling experience. How is the data going to be modeled and integrated together so that it can be easily consumed by the end users? Some of the programming skills that are used by data engineers are SQL, Python, and Hadoop. Note that some of these programming skills are also used by data scientists as well. And this list is not inclusive of all the programming languages that might be used by a data engineer. Knowledge of data governance to secure, cleanse, standardize, format, and join the data to give it structure, context, and clear meaning. A data engineer needs to be knowledgeable of data security and have an understanding of how that data can be secured to limit data or just individual certain fields within a table to certain teams or departments. Finally, data engineers need to have an understanding of regulatory restrictions around the data. And a few of these regulatory restrictions are HIPAA, the Health Insurance Portability and Accountability Act of 1996, PII, Personally Identifiable Information, PHI, Protected Health Information, CCPA, the California Consumer Privacy Act, PIP-EDA, which is the Personal Information Protection and Electronic Documents, and PCI-DSS, which is the Payment Credit Card Industry Data Security Standards. As this is just in this list of regulatory restrictions is just a few that are out there, and there's probably many more out there that are not included in this list. So as you can see, a data engineer wears many hats and has a wide variety of skills and knowledge. While we've established what data engineering is and the skills that are needed, let's discuss the data landscape and the grouping of data and the users who consume it. So we've divided our data landscape into 4 quadrants: innovation and exploration, establishing value, core, and expanding, understanding, and investigation. The vertical axis are business questions, and the horizontal axis data with known and unknown sections. Data flows between the quadrants from the upper right down toward the lower left and then back up. So we'll start with the data exploration in the upper right. As we start to understand what business questions need answered, we move toward the establishing value quadrant. Here we figure out what are the right data sources to answer the questions. We give the business value to the data. Now we move to the lower left quadrant because we understand the questions and what data can be used to answer them. In the core quadrant, we apply structure, context, and optimize the data for use. We purpose the data. From here, we move up to the expanding understanding and investigation quadrant, where we start to ask, what else can we do with this data? Now let's overlay the user roles onto this framework. Data analysts and data scientists spend most of their efforts in the innovation and exploration quadrant, working with unknown data to discover unknown business questions, primarily working with machine learning, notebooking, advanced analytics, Python, R, or other exploratory tools. Advanced users, such as business analysts, perform line of business reporting, but they also spend time analyzing data and investigating other ways that they can use the data to solve business problems. They mostly work with known data and known questions. Finally, we have our casual users who spend the majority of their time with known and known questions. They normally don't deal with the unknown business questions. They are the group doing descriptive and diagnostic reporting using tools such as Power BI, Tableau, Click, or even Excel. This group makes up around 90% of the users in most companies. As we move into governance, we talk about what governing means. And governing is the securing, cleansing, standardizing, formatting, and joining the data to give it structure, context, and clear meaning. Again, this is where we're purposing the data. It can be time consuming and expensive to apply governance, so it doesn't make sense to fully govern everything, especially with the unknown data. So as the data becomes more well known and purposed by the users, most likely going to be the data analysts and data scientists, we can apply more governance around it, which would move the data kind of into the known data, known questions category. Also, businesses will invest more when they understand the business. These questions can be answered and solved using a solution, usually from data in the known questions quadrant. The majority of users are working with known questions, so these solutions are perceived to have the bigger business impact. It is much easier to define and understand ROI when you can identify what business questions can be answered or solved. There is potential for ROI with the unknown questions, maybe even a big disruptor type of ROI, but it's difficult to understand, define, and predict as the data is unstructured or ungoverned at that point. As data scientists and data analysts work with the data in the upper right quadrant, like governance and hype, they may find that there is data there that they would like to go through the governance process and can work with the data engineers to make that happen. What tools do data engineers use? Let's take a look. There are many tools in the market today that are used in data engineering. A few of these tools are Alteryx, Hadoop, Spark, SQL, AWS, Azure, Google Cloud, Oracle, Hive, MongoDB, Informatica, MuleSoft, Attunity, and Fivetran. This slide is not intended to be inclusive of all the available tools, as new tools seem to be used every day. Some tools do things better than others, and although a tool may be able to perform a task, there may be a tool that can do it better and more efficient. We've talked about what data engineering is, why it's important, and the skills that are needed. Now let's talk about an example of how Zirous has helped a customer apply data engineering. Let's start with the situation. The customer had report requirements from many vendors that were similar, but not always the same. An example of this is that some of the vendors wanted to fill empty spaces with blank spaces versus a filler value such as a 0. Dates needed to be output in multiple variations depending on the vendor's requirements. Certain fields needed to be translated to values for each vendor, and file outputs could be fixed width, Excel, or delimited. The individual reports were ran each month for each recipient, and although they were scheduled, they contained complex queries that took a long time to run. Most of the reports used the same data sources and complex queries and had similar logic across each report. This overall process took anywhere from 3 to 7 days to complete, and most had some sort of manual intervention at the end before they could be delivered to the vendor. What action did we take to help fix this? We created a data pipeline to get data from multiple data sources into a single target source. We cleansed the data and formatted through the data pipeline process by replacing null values with zeros and numeric fields and null values with blanks in text fields. We formatted dates into multiple formats so the report developer could select the appropriate format needed for each vendor report. We translated state names into 2-character abbreviations and translated values into new values that were needed for each report, just to name it a few things that we did as part of the process. In the end, we developed data marts where the logic is maintained only one time for all reports. What was the result of our work? All reports are now sourced from the same data mart. If logic changes are needed or need to be added, that can be done in one spot and used for all the vendor reports. The process that took normally 3 to 7 days before now takes less than 1 day, and it's a lot less manual intervention. And finally, the onboarding of new clients and new reports is much faster as the reports use the existing data marts and have not had to start from scratch and recreate everything from the very beginning. As you have seen, data engineering plays an important part in the data journey. Getting reliable, clean, and easy to use data can save time and money as it allows the data analysts and data scientists to do what they do best and turn data into useful information. Having reliable and consistent data can provide management with confidence that the reports that they are being produced are accurate and that they can be used to make good business decisions. Thank you for your time today and learning about data engineering. Now I'll send it back to Brandon.
Thank you, Justin, for delivering such an excellent presentation. And thanks to all of you who joined us for the presentation. As you can tell, we love data engineering and would welcome the opportunity to consult with your organization. Please visit us at zirous.com to find out more information about our services. Take care and stay safe.